My name is Walter Grayman, and I'm representing the Environmental and Water Resources Institute, EWRI's WDSA History Project. The purpose of this project is to document the history of water distribution system analysis. An important part of this project is a series of interviews with engineers, modelers, researchers, and practitioners who have made significant contributions to the field of water distribution system analysis. Our interview today is with Morris Maslia. Morris is a research engineer in the Agency for Toxic Substances and Disease Registry, ATSDR. This interview is being conducted on May 16, 2015 in Austin, Texas. Morris, prior to your involvement with several landmark epidemiology studies at ATSDR, you were primarily a groundwater hydrologist. Did you find it difficult to transition to the analysis of water distribution systems?
Okay, thank you, Walter. Actually, what I found the most difficult in that in groundwater you have very limited data. Even with remediation data, you may get quarterly readings, and in long-term wells, you may get one annual reading or every couple of years, whereas with water distribution system data, or analysis, we almost have an abundance of data because we can get minute, 5-minute, 15-minute intervals from SCADA data. And that's almost becomes more problematic as to how to handle all that data.
During your career with ATSDR, you've been lead investigator on two very high-profile epidemiology studies in New Jersey and then in North Carolina. In this type of retrospective modeling studies, you are attempting to model events that occurred decades previously, and there are many challenges associated with reconstructing such events. Can you talk about your approach to modeling the water distribution systems in these two studies and the innovations that you introduced to accomplish these tasks?
Sure, there are a number of innovations. I think that the biggest or the most wide-ranging one is that we could actually reduce the uncertainty that historically epidemiological studies have encountered through using rat models or even pharmacokinetic models with water distribution system models. And that's an enhancement that the epidemiologists benefit from and is an offshoot from water distribution system modeling that was really never envisioned. The other, I think, enhancement is data archaeology, to quote Tom Walsky from one of our projects, is that you really have to go back and dig very deeply for some basic information that probably has never been thought of to keep records from. And we introduced sort of a procedure or a protocol on how to filter this data, how to look for keywords, and how to make use of find very limited data. And finally, what we were able to do, whereas a lot of times we're going forward or trying to assess a present condition of a water distribution system, we really introduced a methodology through also using a geographic information system of how to subtract pipelines out and go back to the original or very early stages of a water distribution system.
As part of your studies, you used several outside experts to formally review your modeling work. Some names that come to mind include Lou Rossman, developer EPANet, and the late Peter Murphy, who was one of the first to apply water distribution system modeling as part of historical contamination reconstruction studies. Can you talk about your experiences with these and other modelers?
Sure. Working with Lou was both a privilege and really a collaborative effort. Found out about EPANet some years ago, right after they published the initial version of EPANet. I was at a conference in Rome. And at that time, my agency actually was part or had a line item budget as part of EPA Superfund. So we reached out to Lou because we were looking at doing the Toms River water distribution system, and because of what the epidemiologists needed and the politics involved, we wanted to go to an all pipes model. And at that point, the EPA net example problems maybe contained several dozen to maybe 100 pipe segments. And we immediately went up to about 15,000 pipe segments, which under the old DOS system could not handle. So we called up Lou, and his first question was, why do you need so many pipes in there? And we sort of collaborated with them to get it to work under the old DOS system, and also some of the things that we needed for our study he added in to enhancements of the next version of EPA net, and he also served as reviewer as well. So it was a real privilege to work with the developer of EPA net and know that we had some small contribution. Peter Murphy was just a wealth of information because he had done a model of the Woburn system, which the Centers for Disease Control, which is a parent agency of ATSDR, had done a health study, and Peter really provided insights onto what type of information we needed, how to model, how to handle the supply wells within the distribution system. And finally, he really left us a legacy because I have his two original reports that he did on Woburn, which I don't believe, except for the library where he was doing the study at University of Massachusetts, anyone else has.
Both of your studies, the Tom River study in New Jersey and the Camp Lejeune study in North Carolina, were very high profile and required an interface with a variety of people and groups that were very passionate about the impacts and results of the study. Can you tell us about the challenges involved in this and how it differs from more routine modeling studies?
Sure. As you mentioned, they're both very high profile, very political, and also both have very opposing views by the different parties. One of the goals that I saw for ATSDR as an independent agency was to facilitate the communication between the various groups. And in Toms River, we were successful in doing that because we were able to convince all parties to put any legal ramifications on a moratorium for about 2 years or 3 years while we completed the modeling study and then let the results speak for themselves. And that was very successful. Both the private parties, as well as the citizens group, as well as the water company, went along with that. And at our insistence, everything was made in the public domain. With Camp Lejeune, that was much more problematic because we were dealing with the military. And by nature, the military is not in favor of public disclosure just because of their philosophy and the business that they're in. ATSDR, being a public health agency, makes everything public. So in addition, whereas in Toms River we had local, state, and federal agencies cooperating with each other, at Camp Lejeune we really only had 2 federal agencies, ATSDR and then the military, and then we had the public, which was dispersed all over the world, the former Marines and civilian workers. So Camp Lejeune was both from a water distribution, water resources, contaminant analysis standpoint, far more complex, and from the political and logistical standpoint was extremely more complex. And you really did miss that interaction between the local, the state, and the federal agencies to help the public or facilitate the understanding of the complex nature for the public.
Any other thoughts that you'd like to share with us about your work in water distribution system analysis and directions for the future?
Okay. Well, what I'm hoping that people see, both students, practitioners, academicians, is that we were able to take a modeling platform like EPANet or groundwater flow models in the case also of Camp Lejeune, and use them in a way that they were really never intended or envisioned to be used. In this case, to enhance epidemiological studies. We were able to reduce uncertainty from maybe 3 orders of magnitude down to 1 or less than 1 order of magnitude. And that enhanced or provided the ability for the epidemiologists to make some health calls that they would not have been able to make otherwise. And I believe that and the public nature of what we did by allowing all the information, once results are final, to be in the public domain provides an enhancement and a contribution both to the epidemiological literature as well as to maybe future directions that water distribution system and water resources needs to go. Just one other thought, sort of a philosophical thought, is there's a tendency, I think, today for public policy to try to dictate to scientists and engineers what they want or what they need. And I believe that as engineers and scientists, we should get the facts, get the data, and let public policy be formed upon those results.
Thank you very much.
Thank you.